This lesson is for Advanced Algebra, Lesson 5.1 on inequalities and compound sentences. One thing that's not covered in the lesson that is important for students to take note of is that they should be copying the properties that are listed in their book on page 303. Let's begin by just reviewing all 6 of the inequality symbols that exist: the less than symbol, the greater than symbol, the less than or equal to, greater than or equal to symbols, the not equal to symbol, and the approximately equal to symbol. So these are the 6 inequality symbols that students should be comfortable naming and knowing, in particular being able to identify the difference between less than and greater than. Back when I first learned less than and greater than as inequalities, my teacher taught me that the inequality symbols look like a mouth, kind of like an alligator's mouth with teeth, and that the larger number is the one that the symbol is going to bite down or eat. That was helpful for me to know how to set up the inequality, but it didn't help me remember which one was which. Another teacher later on informed me, when I expressed concern about trying to remember which one was which, that the symbol that points to the left, almost like an arrow, is the less than symbol. Since both of those start with L, it was then infinitely easier for me to remember that the one that points to the left like an arrow is less than, the one that points to the right is greater than. When students put inequalities together with a number and a letter, the answer is referred to as an interval. Our focus for the first part of the lesson is on compound inequalities. A compound inequality is when 2 inequalities are put together, also sometimes referred to as a double inequality. Oftentimes a compound inequality will be referred to with words, and students will need to create them from those words and put them into symbol form. If you're trying to describe numbers that go from 3 to 4, that would mean that 3 and 4 are included and all the numbers in between them. So this is what that inequality would look like. You would choose a variable. In this case I chose the variable x, and I want to know that 3 and 4 are included, so I would use the less than or equal to symbol. And all the numbers in between 3 and 4, including 3 and 4, would be included in that compound inequality. If we're talking about numbers only in between 3 and 4, now 3 and 4 themselves are not included. So now we would use just the less than symbol without the equal sign. If we talk about numbers that are at least 3 and less than 4, that means 3 is included but 4 isn't. So now we would use a mixture of inequalities, one with an equal to sign and the other without. And then similarly for our last one, more than 3 but 4 or less means that 3 is not included but 4 is. So students need to be able to go back and forth between the symbol form and the word form of compound inequalities. Other types of compound inequalities that students will encounter are the intersection and the union. When you're combining 2 inequalities with the word and, we're talking about only numbers that are in both of these at the same time. So we call that the intersection of the 2 inequalities. Visually, if you use a Venn diagram that I'm hoping students are currently familiar with, the values that would satisfy both inequalities would be contained within the overlap only of the Venn diagram. The symbol used for the intersection of 2 inequalities is this upside down U shape. Typically when you graph an intersection of 2 inequalities on a number line, usually the picture that's formed will look similar to this. I refer to that shape as like a barbell shape or like a dumbbell. Keep in mind that the circles may or may not be filled in. Sometimes they will be open. So when you're working with an intersection or 2 inequalities joined with the word and, you're finding a set consisting of values that are common to both sets. And that definition was given from page 301. When you combine 2 inequalities with the word or, now you've moved into a type of compound sentence called a union. If you were picturing the union with a Venn diagram, you would include all the elements in both sets at the same time. So that's why this Venn diagram has been completely highlighted. The symbol for union is this U shape. Typically when you graph union on a number line, you'll have two arrows pointing in opposite directions. To describe the union in words, again from the definition from the textbook, page 302, the union of two inequalities is a set consisting of values that are in either set or both. So let's try some of these in graphical form. So here we have the typical way that a compound inequality using and or will look, and how we're going to go about graphing them on a number line. So the first one, the one on the left here, shows that our variable is x. Remember that the vertical bar here means such that. And then we have two inequalities separated by the word and. There's one little issue here with this first inequality that I want to point out. Most of the time students are more comfortable having the variable on the left. So if students would like to, they are allowed to rewrite the inequality so that it's in the format that they find preferable. If I do switch the x to being on the left of the inequality symbol, I want to make sure that the opening for the larger number is still pointing at the x. So I want to switch the direction of that inequality to make sure that it has the same value as the original. So now I have x is greater than 4 and x has to be less than or equal to 8. So if I want to picture numbers that satisfy both of those at the same time, I would draw that on a number line. Make sure when you draw your number line that you use a consistent and equal scale. Usually when you draw your number line, the numbers go underneath, and I'm just using the grid marks here to help me. I don't need to label everything, I just need to make sure that my labels are consistent. Since I don't want the number 4 included, but it is where the numbers start, I want to put an open circle at the 4. I know I'm going to include numbers that are to the right of that, and I'll include those in one moment. I want to include the number 8, so I'm going to go ahead and fill in a closed circle at the 8, and I know I want numbers less than that, so that would be pointing to the left. Since this one points to the right and this one points left, and I only want the numbers that overlap between the two, I would simply draw a filled in line between the two dots. And that would be a physical representation of graphing this compound inequality on a number line. And it looks the way I expected it to. It looks a little bit like a barbell or a dumbbell like I had thought. I'm going to do the same thing on our second example with the letter N. By the way, back on our previous example, make sure you label the number line with the variable that you're working with. So I'm going to go ahead and draw this number line for our second example. This number line represents the letter N, and this time we're looking at a compound sentence with the word or. So we know that we're talking about numbers that are here or there. So again, I'm going to include some values in a consistent fashion. I'm going to label a few of them, and I'm going to put in circles at the 0 and the 5. I don't want 0 or 5 included, so I'm going to use open circles in both locations. For the N on the left, I want numbers smaller than 0, so that would point to the left. So I fill in my arrow to the left direction on the number line. For the other inequality, N is greater than 5, so those would be numbers that are pointing to the right. So I fill in my number line with a thicker line to the right. And then I just put in my arrow. And again, that graph looks the way I anticipated. It's two arrows pointing in opposite directions. Now I'd like students to give this a try on their own. Go ahead and try both of these in your own time. Pause the video to do so, and the answer will appear shortly. And this is what students should come up with, something similar to both of those. The key to knowing if you got it right or not is looking at the numbers to make sure that the line is labeled with the proper letter, and also that the numbers themselves have open circles on both examples. In the first example, or the one on the left, the dots should be connected, And on the second example, the one on the right, the dots should have arrows pointing in opposite directions. There are some tricky ones that I want students to watch out for that I want to describe here. The one on the left here has the word or, so when I graph that, I'm anticipating that I will have two dots pointing in opposite directions. But as you can see here, these inequalities are pointing towards each other. If I want to pick numbers that are greater than 1, I would put an open circle at 1, and then I would think about numbers that would be to the right of that. If I have this inequality, I'd have my open circle at the 4, and I'd want to include numbers that are smaller than that. Since this is an OR, I don't need numbers that satisfy both at the same time, I just need one or the other. Everything greater than 1 is going to point this direction. Everything less than 4 is going to point that direction. When this one points to the right, it's going to overlap or go over the top of the 4 that I'm not including. When I do this inequality, it's going to start from that number and go to the left, and it would again cover over or include the one that it should be an open circle from the other inequality. So if you think about this logically, any number you can think of is either greater than 1 or less than 4. There is no number that doesn't work in either one of those. There are numbers that work in both. For example, the number 2 is greater than 1 and at the same time less than 4. All it has to do is satisfy 1 and it qualifies. So that means every number we can think of satisfies either one of those. So all we would need to do is include some values on the number line, and then we would simply draw a line over the top to indicate that all values will work. So that one's a tricky one because, again, students tend to believe that because it says OR, it should have values that point in opposite directions. This one does have that, but because they overlap, it would include every value. Similarly, for the one on the right, this one says AND, so we're trying to find numbers that work in both inequalities at the same time. So let's try to think of numbers that are smaller than 1. They'd be pointing to the left. And then I would also need values that at the same time are greater than 4, and that would be pointing to the right. In order for this to work, I'd need numbers that work in both inequalities simultaneously. I can't think of a number that's smaller than 1 while at the same time is also greater than 4. No number exists. So I wouldn't be able to draw a number line to answer this question. I simply say no solution. So I wanted to point out those two examples for students just so that when they come across them they know what to expect. Finally in this video, we're going to look at a more practical example of where inequalities come out to play in real life. By the way, when you're solving inequalities, there's one thing you have to watch out for. If you multiply or divide when you're solving an inequality by a negative number, you must switch the direction of the inequality. It's important for students to note this because when you multiply or divide by a negative, typically what happens is the value of the number changes from being positive to negative or from negative to positive. What happens then is on a number line you're changing directions. You're moving from a negative, which would be less than 0, to a positive, which would be greater than 0. So it's important for students to switch the direction of the inequality because of the nature of negative numbers themselves. Our example here for solving involves a skittle truck. A truck stops at a weigh station. Those are typically seen on the freeway or the highway, and is found to weigh 5,000 pounds. It has cargo of 50-pound bags of Skittles, which would certainly be a dream come true. Write an expression to represent the weight of the truck without its cargo. It's important for trucks hauling large loads that they are weighed properly so that they do not damage the roadway. So if the skittle truck weighs too much, it might be important for them to unload some of their product. If the truck weighs 5,000 and we take out the 50-pound bags of Skittles, that would mean we're removing them. Mathematically, that would be a subtraction. And let's just pick a variable to represent the number of bags of Skittles. S would be a good choice here. However, I know personally when I write 5s and S's, they tend to look similar, which could potentially be confusing. So I'm going to use K to represent my bags of Skittles. How many bags should be removed then from the truck if the weight limit is 4,200? Keyword here is the weight limit. If I take my expression from the previous question, I know I'm going to need some kind of an inequality symbol and my 4,200. Remember that this represents the truck itself, and it can't weigh more than 4,200. It could equal that amount, but it has to be that number or less. That is the nature of having a weight limit. So I know that the symbol I need here is the less than or equal to sign. Now I'm going to go ahead and solve that and graph my solution on a number line. So from here you simply pretend that this was an equal sign, and you behave just like you would when you solve a regular equation. You're trying to get the k alone, so we're going to subtract 5,000 from both sides. It's a common thing here for students to mistakenly believe that they need to add 5,000 to both sides because they focus on this subtraction symbol. Remember that the thing that's being subtracted here is the 50, not the 5,000. We want that 5,000 to go away. So if we added it, it would become 10,000, which makes it bigger, not smaller. When I simplify on the right, I get negative 800. Now to solve, I'm going to divide both sides by negative 50. Remembering here that when you divide by a negative with an inequality, the direction of the inequality must change directions or change the way that it points. Negative divided by negative is positive, and that's the reason that the direction has to change. And so we end up with 16. So the driver of the Skittle truck needs to remove a minimum of 16 bags in order for it to reach the proper weight limit. If it removes more than 16, it will be well below the weight limit, but it must remove 16. This is a single inequality, or another word for it is an interval. And so when we graph it on a number line, we simply need to include where 16 is and then draw our arrow one direction. This is not a compound inequality, so we won't get a dumbbell or a barbell, and we won't get two arrows pointing in opposite directions. We'll simply have one arrow. So I decided to go by 2s in order to maintain enough space on my number line. And I know that 16 is included, so I'm going to put a filled in circle. And I want to go to the right, because those are where the numbers are greater than 0. Or excuse me, greater than 16. So I draw my arrow to the right.